Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 2.4, which is titled Special Polynomials. This is an extension of 2.3, which is multiplying polynomials. What we find in 2.4 is that there are special cases, particularly when we're looking at binomials, that when we multiply them, there are certain patterns that we recognize. And so in other words, if we remember these patterns, then we should be able to either multiply or in some cases later on in Unit 3, factor these without having to do all of the arithmetic. So these are meant to be shortcuts, and just like when we learned the rules of exponents, while they are meant to be shortcuts, if you ever forget them, you can always do it the long way and still come to the same answer. So these are super important. They're going to come up throughout the year, throughout Integrated Math 3 and beyond. So if you don't have them in your notes already, I recommend that you do so. The first, you have a plus or minus b quantity squared, which is going to be equal to a squared plus or minus 2ab plus b squared. For some of you, that symbol may be new, the plus or minus sign. And so anytime you have a plus or minus sign in the formula, you want to pay attention to where it lands in the expanded form. So here, when I have a plus or minus b, and I have a plus or minus b here, it's saying that whatever that symbol is inside the parentheses, inside the binomial, I need it to be the same symbol when I expand. What this is doing is, in terms of formula, is really saving me space on like a formula sheet or a cheat sheet. So if I have a plus b quantity squared, for instance, that's a squared plus 2ab plus b squared. And if I had a minus b quantity squared, that would be a squared minus 2ab plus b squared. So it's a way of condensing these two formulas into a single formula. Okay? So this perfect square binomial, what does this look like? Well, if I have something like x plus 3 quantity squared, for instance, and I ask you to expand that, then in theory, if you're using this formula, you take the first term, a, or x in this case, squared, plus 2 times the first term, x, times the second term, 3, and then plus 3 squared. So you multiply that out, 2 times 3, you get 6x, and then 3 squared, you get 9. You could still get this, again, if you forgot the formula, by just doing x plus 3 times itself. And just like we did in 2.3, you can use FOIL, you can use the box method, but you would do x times x, you would do x times 3, and then 3 times x, and then 3 times 3. Combine like terms, and you still get x squared plus 6x plus 9. Well, if you're looking at what I just wrote, those two kind of look like the same amount of work. But especially when it's a smaller example, like here I put x and 3, there's no fractions, there's no decimal values there, no huge coefficients, then you could probably do the mental math in your head to come to the 6x and the 9 rather than having to write out these steps. Again, it's meant as a shortcut, and it'll come in handy, especially as we get into quadratic functions and graphing quadratic functions. Let's look at another example. Let's do x minus 9 quantity squared. So I do the first term squared. Remember, it's plus or minus, so if there's a minus sign inside the parentheses, I need to have a minus here for my middle term. 2 times x times 9, and then plus 81. I get x squared minus 18x plus 81. Remember, your middle term is the only one that's changing sign. Because we are squaring the left and right terms, the first term and the third term, or the quadratic term and the constant term, will always be positive. The only term that potentially can change is the linear term in the middle, and that's going to change based on what sign is in the parentheses set. 2x minus 1 quantity squared. So be careful here. In the first couple examples, we were just looking at an x with a 1 as a coefficient. So your formula is the first term squared minus 2 times the first term times the second term plus the second term squared. So when you have a quantity squared, like 2x squared, you need to square both the coefficient and the x. So that's 4x squared minus 2 times 2x gives me 4x, and then 1 squared gives me 1. All right, let's look at one more. 3x minus 7 quantity squared. Let me go plus 3x plus 7 quantity squared. So I do 3x squared plus 2 times 3x times 7 plus the second term squared. 3x quantity squared gives me 9x squared. 2 times 3 times 7 gives me 42x. And then 7 squared gives me 49. So that's one of the special cases that you're expected to know. The second is what's known as difference of squares. And so this formula looks as such, where you have a plus b times a minus b. That yields a squared minus b squared, thus the difference of terms name. So anytime you have a binomial that's being multiplied by its conjugate, if you were to do FOIL or the box method, the middle terms cancel out, and all that you're left with is the first term squared minus the second term squared. So x plus 5 times x minus 5, for instance. This formula tells me that because I'm multiplying a binomial by its conjugate, I should get the first term squared minus the second term squared. And if I forgot that formula, I could always do it out the long way. X times x, x times negative 5, 5 times x, and 5 times negative 5. And just as we mentioned here, the middle terms would cancel out, leaving you with x squared minus 25. So a shortcut, if you remember it. If you don't, you can always just multiply it out like we did in 2.3. X plus 8 times x minus 8. First term squared minus the second term squared. X plus 10 times x minus 10. First term squared minus the second term squared. And so on and so forth. We're going to see a lot of those examples once we get into Unit 3, so you want to be familiar with this formula. Remember that if your first term is not a basic x, 3x minus 2 times 3x plus 2, remember it is that term squared. So in this case, 3x squared, 3x quantity squared, would yield 9x squared. And then 2 squared is just 4. Your x term doesn't always have to be on the left side of the binomial. Usually it is, but not always. So for instance, if I had 1 minus 6x times 1 plus 6x, even though the x term is on the right instead of the left of the binomial, it's the same process. I would do the first term squared minus the second term squared. And last for this section for special polynomials is the binomial cubed. We're going to spend more time in 2.5 on binomial expansion, looking at how you expand a binomial of higher powers. And we'll talk about the Pascal triangle and what that looks like. But basically, if you have a power to the third, you're going to have your first term cubed. Your last term is going to be cubed. And then what you do with the middle terms is a, the power, is going to go down. And then b power is going to go up. So notice here my a power went from 3, 2, 1, 0. And my b power went from 0, 1, 2, 3. And in the middle here, we're going to have two coefficients of 3. We'll talk more about that in 2.5, where those 3 come from and what it'll look like if I have a plus b to the 4th power to the 10th power. But this is the expansion of a binomial to the 3rd power. If I forgot this formula, again, I could always do it out the long way. So I have a plus b times a plus b times a plus b. That's what a plus b cubed means. So you do a times a times a times a times b, a times b times a times b times b. And this is what I'm doing here, a times a times a and then a times b, a times b times a times b, and then I would do b times a times a, b times a times b, and then b times b times a, and then b times b times b. So then you just combine your like terms, and once all that's done, so 1, 2, 3, and 1, 2, 3, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. That's how we derive the formula. Remember, 2 times 2 times 2, I should have gotten 8 terms, which I do have here. But if you remember the formula, then you don't have to do all of that arithmetic. So let's do an example. A plus b quantity cubed. So let's do something basic. X plus 2 quantity cubed. So going through carefully, my first term cubed plus 3 times my second term squared times the first term plus 3 times my first term times my second term squared plus the last term cubed. Then it's just a matter of simplifying your coefficients. So 3 times 2, I get 6, x squared. 2 squared is 4 times 3 gives me 12x. And then 2 cubed gives me 8. Do another example. X, x plus 5 quantity cubed. So first term cubed plus 3 times the first term squared times the second term plus 3 times the first term times the second term squared plus the second term cubed. So I have x cubed. 3 times 5 gives me 15. 5 squared is 25 times 3 gives me 75. And then 5 cubed gets me 125. Now, with the binomial term where we had a plus b quantity squared, we were using that plus or minus sign, showing that two formulas can be combined into a single formula. With with a sum or difference binomial cubed, it's going to be a little bit different. Because it's a third power, it's an odd power, the signs aren't always going to be the same. Instead, they're going to alternate. So here, if I have a plus or minus b quantity cubed, it's going to be a cubed, and then it's going to alternate from there. So it'll be minus or plus 3a squared b plus or minus 3a squared b minus or plus b cubed. So just like in the previous formula where we saw plus or minus, and we said whatever the sign is, it has to be the same. If I see that sign flipped, minus or plus, then it needs to be the opposite. So for instance, here, if I have a binomial to the third power where I have a minus b, in expanded form, that's going to be a cubed, and then we're going to take the opposite sign, or the same sign rather. It's going to be minus 3a squared b plus, then it's going to be minus 3ab squared, and then plus b cubed. Oh, hang on. Sorry about that. Let's step back here a second. I mucked it up here. So in the top here, same thing down here. What it should be is the same sign, and then the opposite sign, and then the same sign. So here it's going to be the same, and then the opposite, and then the same. So let's do an example. If I have x minus 2 quantity cubed, it is your first term cubed minus 3 times the first term squared times the second term plus 3 times the first term times the second term squared, and then minus the second term cubed. So I have x cubed, 3 times 2, 6x squared, 3 times 2 squared gives me 12x, and then 2 cubed gives me 8. So if the sign is positive, then all terms are going to be positive. If it is different, then it's going to alternate down the line there. All right, guys, that's all for today. If you have any questions, please reach out to me, and I will talk to you soon.